Good morning, everyone, and welcome. Welcome to day 4, final day of the Sustainable Places Conference. Today, what we'll do is we'll actually switch the presentations because we're having a little technical trouble.
Thank you so much for having me. I appreciate the chance to be here. Talk about a subject that is definitely near and dear to my heart personally. We are, as has been discussed, we're going to be talking about what I see as both the opportunity and truly an imperative for us to think about and evolve to more circular economic models in the tech sector. And the reason why is because we are operating collectively, all of us, at unprecedented scale and in the sector, and technology enables everything that we think about and do today in our personal lives, professional lives, and so forth, especially more so even now. That scale has the potential to have massive impact, both positive and negative. And we think circular economic models are a really important piece of the puzzle as we seek to capitalize on the positive potential and minimize the negative potential. So just, you know, some basic context on circular economic models that will hope to give people the right framework to think about this as we go into the session. In the traditional kind of model that the world has operated in for decades now, we think of it as very linear, right? So we take resources, we make things with those resources, and then we too often dispose of them. And recycling is actually disposing as well, right? So it's better than landfill, but it's still disposing, right? We think of things as having sort of singular use cases, right? We you know, since probably the middle of the last century have moved towards what is truly too much of a disposable and consumption-driven economic model, and that model has proved to put us in a place where we are really depleting the Earth's resources in a way that's unsustainable, right? It turns out that it's also the model that doesn't maximize the financial value of resources and things, and we'll talk about that. But so it's super important opportunity now to be thinking about how do we move towards a more circular model, and that's what we're going to talk about today. I'm going to first set some context for kind of that scale and the potential, both positive and negative, that I mentioned at the beginning. And then we're going to focus on the data center industry as a subset of the technology industry, where, you know, we have some really interesting research that we've done to talk about and to characterize the data and the potential, and because it's happening now, right? It's a good sort of mini case study as to how we can think about moving towards more circular models more holistically across the tech sector. Very quickly, first, who's ITRenew? We are in this business, right? We operationalize and orchestrate circular data center models and circular economic IT models. We work with most of the major hyperscale cloud companies to help them think about how they maximize lifetime value of assets, how they think about life cycle management. We physically decommission equipment from those environments, and then we create secondary markets for all of this equipment, which, as you'll learn more, is the circular model, right? We're creating secondary lives, in some cases tertiary lives, and as we do that, we're maximizing both the financial value of assets, IT assets, but also the sustainability value. And you know, our belief is that to do the right thing to maximize financial value, to maximize the positive potential of technology, is not in conflict with what maximizes the sustainability value, right? It's a core part of our mission to say we want to believe, we want to foster growth in the tech sector, we want to unleash the potential of it at scale in all the best ways, and none of that should be in conflict with doing the right thing from an environmental perspective. So let's just dive in. Scale. IDC says that the global IT hardware industry, IT industry is about $5.2 trillion in 2020. The hardware portion of that, devices and infrastructure, is over $1 trillion, 1.2. That's the 5.2 number is the largest industry in the world, right? For context, and this is very positive context, it's bigger, for example, than the global oil and gas industry, which is about 3.3 trillion, right? So the good news is we are spending money on technology, and we are investing in technology for a variety of very positive use cases, which is, again, at a scale which is almost hard to fathom, right? Other ways of looking at this, right? There are about 13 billion connected devices now in 2020, and the expectation from markets and research and Grandview research is that that number goes to 75 billion over the next 5 years. So again, about average of about 10 devices per person globally. If you think about that at scale, in all corners of the world, it's an immense amount of devices that are connecting over the internet and generating a tremendous amount of data that feeds, again, very positive potential, but requires a tremendous amount of resources to deliver, right? Same time, those devices, and we all, and our applications, everything that we do professionally, personally, and so forth, is expected to generate about 520 zettabytes of data by 2025. It's super hard for people to understand what a zettabyte is. So I wanted to share my favorite stat, which is that some people are estimating that a zettabyte, a single zettabyte, is the equivalent amount of information to all of the grades of sand in all of the world's beaches globally, right? So again, impossible to fathom the beaches around Barcelona, the beaches everywhere around the world. Take that and multiply it by 520, and that's the amount of data in terms of information that we're going to process and do something with in the next 5 years. So again, just driving almost unfathomable demand for infrastructure, both hardware and software. And of course, we're going to focus on hardware today because that's the stuff that consumes the physical materials. But it's obviously a massive amount of information that's driving all of this. Now, from a positive potential perspective, all of this investment in technology enables massively interesting things, right? It enables everything that we see in healthcare, especially we're seeing telehealth now. It enables everything we see in, whether it's from smart manufacturing, autonomous vehicles, space travel, climate science, you name it, right? We as an industry, people operating in the cloud sector, people operating in the various application sector, we have the ability to harness technology to do amazing things, right? I mean, people talk about superhuman computing in the not too distant future, right? Immense potential. And the question I often pose, though, is, we talk a lot about clouds. Are our heads in the clouds, right? At what cost is all of this phenomenal investment in technology? And that's where we're going to talk today about how we can potentially turn these things into less costly and more impactful. Couple stats here. Just to showcase again the potential, sort of the imperative really behind this. We generate about 50 million tons of e-waste every year as an industry. To put that in context, that's if you stacked like 18-wheel trucks front to back from New York to Bangkok and back, full of e-waste every year. That number is growing. People are talking about the fact that we need to start mining the deep sea beds for the minerals that are going to make up electronics, because we're going to completely deplete all of the land-based sources for those minerals within the next 10 to 15 years. We're using a tremendous amount of energy, right? There's an estimate that says we're going to consume more power in the tech sector than full energy produced by 2040. Things like AI are, again, incredibly powerful tools, but come at a big cost, right? So there's another forecast that within the next few years, AI alone could amount for as much as 10% or more of the global energy demands. And as a sector, the most alarming stat, and the stat that I think should compel all of us to really think about how we work together to change some of the practices and become more sustainable, is that as an industry, digital industry, we are on track to go from about 4% of the world's greenhouse gases to as much as 8% in the not too distant future, right? And what that basically means is that as the global community is working really hard to decrease emissions and to work towards the climate change principles of 2 degrees and 4 degrees and so forth, as an industry, we're going the wrong direction, right? We're going from a relatively lesser to a more high percent. And that just tells me we've got to work together to try to think about how we drive innovation differently than we have in the past. The last piece about this is really a humanitarian piece. And the question I would pose is, all of those immense power and potential, positive potential of the tech sector, is it really distributed evenly, right? And it turns out that still, we're getting better. A few years ago, it was half the world's population is not online. The most recent stat this year is about 41% is not online. So we are getting better, which is very interesting. Unfortunately, there's a tremendous amount of e-waste still that goes to, not coincidentally, the same places in the world where the population is not online. So we have kind of a 1-2 punch of some of the developing countries are still hindered by lack of access to infrastructure, lack of access to technology, and populations that are not online and therefore not generating as much economic growth, prosperity, and so forth. But we're also then shipping back a bunch of e-waste, right? So there's sort of a compounding problem in parts of the world that is problematic to all of us, not just in various parts of the world, right? And there's an estimate here from the World Bank about 6 or 9 months ago that says if we were able to get the populations in some of these countries that are still developing online to the tune of like 75%, that could generate as much as another $2 trillion US dollars equivalent of economic impact, right? So massive potential to kind of lift the overall global community. And frankly, COVID-19 has exacerbated this kind of unequal distribution of technology and the impact of not having people online, right? If you think about not just economic potential, but what happens if people can't get telehealth? What happens if they can't do online education? What happens if they can't work remotely, right? So anyway, not only an environmental impact, but absolutely a social impact that is tied to and touched by this situation of kind of pervasive technology and the scale that we're all operating at, right? One more point on this for context setting. It's not just me talking about it, right? The UN set out in 2015 some sustainable development goals, and there were a couple that are directly related to this topic, right? The first one is industry, innovation, and infrastructure. This is about that context we just talked about, which is getting people online matters. It's important. It feeds not only the elimination of poverty, which is goal number 1, but it feeds access to education and equal rights and prosperity and so forth, right? Healthcare, everything else. The point that's most important about here is that there's another estimate that says we're about $100 billion shy of the budget required to achieve that universal access goal, which means that the traditional ways of us delivering infrastructure are insufficient. We have to innovate here in order to drive goal number 9 and to get people online, connected, and so forth. At the same time, there's another one which is very straightforward: responsible consumption and production, right? We cannot keep trashing the planet. We're going to run out of resources. Circular economic models would say, hey, let's not just do this kind of single-use disposable world that we live in. Let's actually truly maximize the financial value and the sustainability value of all of the materials. Goes hand in hand with this, right? So this is circular economy kind of 101, right? So let's look at it in practice. In a circular economic model, rather than that linear model, the goal is keep assets in their highest utility value as long as possible, which means that you have this kind of notion of cascading of assets into lesser value situations for as long as possible, wherein recycling and any sort of waste stream is the least worst alternative, right? So the first thing you want to do is, in looking at the data center industry as an example that we're going to dive into here, is say, okay, what if I have racks of equipment, right? I don't want to just recycle those when I'm done with them. I want to actually take those racks and give them a second life as racks. That's the least kind of transformation. It's the least energy input and so forth. If I can't do that, maybe I can turn those same compute and storage resources into things like edge solutions. So in other words, not rack scale, requires a little bit more transformation, but you don't jump all the way to recycling. Same thing in between kind of edge solutions or other remanufactured type, so, form factors. You can think about recertifying and reselling components, right? So we're keeping as much as possible out of the landfill and going through these loops of recertification, remanufacture, reuse as long as possible. And as we do that, in their highest utility value as long as possible, which means that you have this kind of notion of cascading of assets into lesser value situations for as long as possible, wherein recycling and any sort of waste stream is the least worst alternative, right? So the first thing you want to do is, in looking at the data center industry as an example that we're going to dive into here, is say, okay, what if I have racks of equipment, right? I don't want to just recycle those when I'm done with them. I want to actually take those racks and give them a second life as racks. That's the least kind of transformation, it's the least energy input and so forth. If I can't do that, maybe I can turn those same compute and storage resources into things like edge solutions. So in other words, not rack scale, requires a little bit more transformation, but you don't jump all the way to recycling. Same thing in between kind of edge solutions or other remanufactured type, so, form factors. You can think about recertifying and reselling components, right? So we're keeping as much as possible out of the landfill and going through these loops of recertification, remanufacture, reuse that's in their highest utility value as long as possible, which means that you have this kind of notion of cascading of assets into lesser value situations for as long as possible, wherein recycling and any sort of waste stream is the least worst alternative, right? So the first thing you want to do is, in looking at the data center industry as an example that we're going to dive into here, is say, okay, what if I have racks of equipment, right? I don't want to just recycle those when I'm done with them. I want to actually take those racks and give them a second life as racks. That's the least kind of transformation, it's the least energy input and so forth. If I can't do that, maybe I can turn those same compute and storage resources into things like edge solutions. So in other words, not rack scale, requires a little bit more transformation, but you don't jump all the way to recycling. Same thing in between kind of edge solutions or other remanufactured type, so, form factors. You can think about recertifying and reselling components, right? So we're keeping as much as possible out of the landfill and going through these loops of recertification, remanufacture, reuse as long as possible. And as we do that, we're deferring a tremendous amount of new manufacturing, which we'll talk about in a minute, has a very significant carbon impact in addition to just the sheer materials. So that's context. We'll come back to a little bit more of the data center examples in a minute, but some more stats, right? When we talk about e-waste of 50 million metric tons, that's a global stat. In the data center industry, the important stat is servers, right? So these are Gartner numbers that says in data centers that have an average of over 50 servers, 50 racks of servers in them, there are about 65 million servers deployed in 2019. There's about 14 million servers expected to go into those places over the next 4 years. And so you should land at about 120 million servers deployed in the world in these data centers. But unfortunately, what's true is that you end this period of 2023 with 75 million servers. So what that tells you is that there's about 46 million that are coming out over that same amount of time, which again is just a tremendous amount of physical material that's entering the waste stream if we don't do something different with it. So we have this mass challenge, and then we have an energy challenge, right? And the good news is, on the energy challenge side, we are doing a fantastic job, right? You see companies from Microsoft to Google to Iron Mountain to everybody doing a very good job thinking about use phase energy, thinking about deploying green grids, renewable sources of energy and so forth, which is fantastic, right? This is all essential. Nobody can keep that. We have to keep our foot on the gas here, right? Everything that goes into better energy usage. Cooling is a great example, right? We have to make these data centers much, much more efficient. Summer's obviously playing an important role in this. But the question then is, if we're looking just at renewable energies as the solution to the environmental challenges of the data center industry, are we looking at the whole thing? And it turns out that there's some other really important pieces, right? So energy really hits the use phase, right? When I turn on the racks in a data center, what is the cost of that from a power perspective, financially, and an environmental perspective? And the greener the grids we are, the better we are at efficient cooling. This is essential stuff, right? But we did an analysis recently, late last year, that helps to give us a view of where should we look next, right? If we assume success on continuing to drive PUE with all of this, the energy use phase, innovation, where do we look next? And it turns out that if you look at the process of kind of everything that goes into pre-use, right? So mining of materials, manufacture of components, assembly of systems and racks, transportation, and all of that, everything that happens before you get to a data center, that's the pre-use phase, that's part of embodied energy. The other part of embodied energy is everything that happens post-use. So end-of-life practices that involve generally sorting of materials, shredding, smelting, and so forth, right? We did a full life cycle analysis of kind of standard x86 based data center racks, and it turns out the embodied content really, really, really matters, right? So we're doing a pretty good job, as I said, on the use phase stuff. We've driven PUE down immensely in the majority of data centers. We're continuing to do those things. But if 3/4 of the carbon impact of IT equipment is associated with everything that happens before you ever turn it on, then that gives us a really good place to say, huh, what if we could defer that process? What if we could defer that new manufacturing, right? And what deferring that new manufacturing means is, what if we could enable a second life for that equipment, right? Can I buy myself, can I use that same equipment and defer that whole 76%? It turns out that it has a really meaningful impact, right? Because if you think about the fact that 76% of the total carbon impact, the net CO2 equivalent impact, is associated with the pre-use phase, that embodied content, which is shown in the green bar here, then if you decrease that, what happens if you buy a second life is you decrease that portion a lot. Now, you do absolutely have a slightly higher impact to operational cost and carbon because equipment is running longer, but it's far more than offset, right? So the net impact is about 25% as when you move to a circular model as compared to when you're in a linear model, right? And that's all associated with deferring the new manufacturing. Now, to just put that in context, that same increase from a net CO2 perspective is the equivalent of saying I'm going to get 68% better in my use phase energy, right? So, think about what that means from PUE gains. Think about that what that means from other efficiency gains in the data center. That's a big ask, right? We've already squeezed a lot out of the use phase energy. So to get another 60, 70% is a big ask. So this is, a pretty good way of achieving the similar kind of a gain. Now, one of the obvious questions is, well, but wait a minute, does it cost me more, right? I get it from a sustainability perspective. That sounds really good. But are we living in 2015, 2010, where, to do the right thing from a sustainability perspective actually carried a cost and you had to pay more to do the right thing? And the answer is thankfully no, right? If you run these models out and you model out the changes in Moore's law, you model out hardware depreciation, you model out the cost of power, all of these things, utilization in data centers, it turns out that the overall system TCO, which is, again, just the deferral of new manufacturing, is also about 25% better. So significant gains shared by both kind of first life deployment, like the hyperscalers in this case, and second life consumers of the recertified circular equipment, right? So we have a nice opportunity here, which is truly a win-win, which is, hey, I'm going to get the maximal sustainability benefit and I'm going to get better TCO, right? From a waste perspective, also super important. If we just theorize that we could make those 46 million outbound servers that I talked about before, if we could buy them a second life, that would be the equivalent of about over 30 million metric tons of carbon, right? So how big is that? It's almost 7 million cars coming off the road every year. That's an annual number, right? So it's a massive amount of carbon impact that could come just from deferring the new manufacturing of racks in data centers, right? So sounds like a pretty good win. The question is, what does it look like? What does it take to do it? Well, thankfully, open technology, open source hardware, open source software has been really taking the world by storm for the last 5 to 10 years, more on the software side. And that gives us the platform, right? So ITRenew is in the business of doing this recertification of equipment, hyperscale equipment. It's enabled first and foremost by open technology. So super, very important. The open compute community, super important to this. The ODM integration model, super important to this. Our relationships with hyperscalers and the fact that hyperscalers are decommissioning this equipment at massive, massive scale, also really important because that predictability, that availability, the openness gives us the ability to say, okay, these solutions, we can now turn that stuff into solutions that are useful, usable, and accessible by the broader downstream markets. And here's the clincher is that the downstream markets get radically better economics as well, right? So this is what catalyzes and unblocks some of those budget constraints, whether it's the universal access budget constraint or whether it's the fact that if you're a global enterprise, a telco, a tier 2 or 3 cloud service provider, you don't have the budget latitude that a Facebook or a Google or a Microsoft has. You actually have some real constraints. And because we can give you recertified equipment, then you can get it at significantly lower cost than you would get with a proprietary traditional OEM model, right? So suddenly we have the ability to bring things to the markets at scale, predictably, with really significant economics. And the key is, well, again, at what cost, right? Do I have to compromise something, right? And the critical success factor for any circular economic model is it can't be without compromise, right? Everybody on this call, everybody we engage with knows that, like, to do the right thing from a sustainability perspective, for most of human nature, it can't be any more inconvenient, right? It can't come with compromises. It can't be more, it can't require me to do a whole bunch of other stuff, right? It has to be just as easy. And in this case, what that means is no compromise to performance and to quality, and you just focus on outcomes per dollar, right? So if recertified equipment, I can just plug it in, it meets the needs of my use cases, whether that's, you know, Kubernetes, VMware, you know, whatever, OpenShift, or whether that's virtual desktop environments or machine learning environments, whether that's converged environments. If I can just plug this equipment in, and I don't need to worry about, oh, gee, does it not quite give me the right performance or so forth. But if I can match the performance needs of my workload and I get the best outcomes per dollar, then why would I not do that, right? So this is the opportunity we have to do it today, to use the data center industry as a really great example of what is the success recipe for moving towards more circular economic models across the IT industry in general, right? And I would just summarize by saying, you know, again, to the comment I made at the beginning, and I'd, you know, love to get into the full detail of this with anybody and everybody at any time, because you can probably tell I'm passionate about it. We didn't talk much about the financial opportunity here, but we've modeled that we think there's about a $50 billion hyperscale value recovery opportunity here, right? So what that means is that the upstream partners of ITRenew, people like Facebook, like Microsoft, like Google, and others, are motivated to also drive this circular economic model, right? Not only are they driving to carbon negative, not only are they driving to renewables, they have a real financial incentive in addition to a sustainability incentive to help these models succeed. And on the so then it's like, okay, I got upstream incentive. Then on the downstream side, the financial modeling that we've done says that there's probably about a $10 billion a year market for recertified hardware in this fashion, right? So you get kind of a nice matching right hand, left hand of, I have motivation on the upstream side, I have motivation on the downstream side of people who are like, hey, I need my budget to go further. If I don't have to give anything up in terms of quality or performance, I'd absolutely like to get that 50% TCO advantage, right? And then of course, we talked about the sustainability impact, potentially really, really significant from a carbon perspective, and the human impact, which is, what if we could take this 50% TCO advantage of hardware and unleash that 40% of the people that are still not online, unleash that $2 trillion of GDP, but do it in a really sustainable way. So we're not continuing to kind of trash those same environments that we're seeking to benefit, but we can actually really strive to drive the global community towards these sustainable development goals. Then, you know, this feels to me like not just a win-win from a financial perspective, but truly a win-win-win, where we've got kind of both the financial benefit, the sustainability benefit, and the human and social benefit that I think the global community is seeking to achieve, as evidenced in the Sustainable Development Goals.
So thank you, Ali Fenn, for that presentation. Ali is president of ITRenew. Ali won't be joining us for the Q&A, but Bruno Fouquet will be joining us. Bruno is president of ITRenew France. if that's, am I right there in saying that, Bruno? So Bruno, if you just click that red microphone, and that unmutes yourself. There you go. Yeah. So Bruno, Bruno will be joining us today. Bruno will be taking the questions. We start with the first question, which is from, let's see, Christina Kerwin. So let's unmute Christina Kerwin and let her ask her question.
Hello, sorry, maybe I missed. Good morning, everybody. I may miss something. I had some issues with the speakers just a few minutes ago, so I'm just connected. I just can hear now. So
okay,
if anything happened, then please repeat it.
Okay, so thank you for joining us, Bruno. We'll start with the first question. For data center equipment use phase, what grid type was considered in your life cycle assessment, i.e. green grid or standard grid, and how would the results differ?
Can you say again, how good time?
For the data center equipment use phase, what grid type was considered in your LCA, green grid or standard grid, and how would those results differ?
I wouldn't say exactly what. I think we're not grid specific as long as we've got some proper. If we speak about the power supply, I guess, then I would say that we can cover most of the power supply that are available today in Europe, but also in US. So on the deployment standpoint, I should admit that I've never had that type of questions for validating our solution could be deployed or not. So I would say by default, we cover or we support all. But I would be pleased to get more in details offline, maybe on these topics, if there are some more information to get into.
Okay. And the second question there, what software or what method did you use to carry out the LCA? Because there's obviously a variety of different methods that one could use.
For the LCA?
Yeah. For your life cycle assessment, for the how you assess the life cycle.
So today we don't. We've been doing some internal studies together with some IDC information and things like that, and we've built up our own. How do we say? I would say Excel file or algorithm to evaluate how we could reuse our solutions. Know what we think about. Today we consider that the best way of seeing our business model works is we look at the failure rate, which is very, very low. That means by far below 0.5%. So that's another point. And I know that besides that, maybe some of you already heard about CEDaCI group from the Green IT consortium or group or organization that is also working on some software to measure or evaluate or track this life cycle stuff. But today we've got our internal tools.
Okay, so you're using internal tools there. Okay. Okay, so we have the next question from Stefan Frenzel. So I will unmute Stefan so he can ask his own question. So Stefan, if you unmute yourself, you can ask your question. Yeah.
Hi Bruno, how are you doing? Can you hear me?
Hello Stefan. Yes, I can hear you.
This one, it's about the customer. So from my understanding, Bruno, correct me here, your biggest account in Europe when it comes to circular economy is OMV Cloud, right, in France, isn't it?
Oh, sorry, Stefan, the communication is...
Sorry? Can you hear me?
Yes, but not clearly, so I couldn't catch your question properly, I'm afraid.
Okay. Is it better now?
Yeah.
Is it better?
Yeah.
Okay. So basically, I was wondering in Europe, apart from OVH Cloud, I think this is one of your major accounts the headquarters located in France. Which other big accounts you are reaching out, especially in the DACH region, in the German-speaking markets, Austria, Germany, and Switzerland?
Okay. So I will first start to be generic. So we do indeed see good targets in the cloud service providers market.
Mm-hmm.
So we see that to be quite generic, yes, in the answer. Then we see that as long as you've got some end customers having some technical skills and also some need in flexibility while having a large constraints on the TCO topics. So as long as the infrastructure is part of their business model, then our solution does match very well. So not only OVH may consider our solution, but most of the cloud providers we could see in Europe, and also by consequences also in that region. We have started to have some few references in Germany. The few of them, it's a bit early for me to give some names, but the few of them that we have today are cloud provider as well. Besides that, to give you a more complete answer, we more and more see software as a service companies also interested in our solution, and what is still missing to us or to them is the capability to have a co-location open to accepting open hardware systems, or let's say that they do accept it, but the pricing model is not adapted to what we propose yet. So we need some more time. And to finish up on that, over Europe, we also now see very nice references also in banking area, but also in the industry and energy ones.
Because Bruno, as you know, I love what you guys are doing, but whenever I'm talking here to people within the data center industry, in Germany especially, nobody really knows you. People, sorry to say that, but people know OCP. That's a topic. People are really getting into it. But it's when it comes to circular economy or ITRenew, there is a gap at the moment in terms of also knowing you guys. So I'd love to tell you a story, basically, and there's potential in the market, believe me.
So we have okay. I have one excuse and one answer to this. My first excuse is that indeed, after the end of February, my plan was to cover about 2 or 3 cloud events in Germany. Then COVID came, and I guess that you understand what happened. I couldn't move on the region, and then it's not helpful to make us known. However, besides that, I can already say that we've got an open source process engineer based in Germany, and I'm doing some hiring today. That we think it will be very, it will bring a lot of value in having a local technical resources in the DACH region, and more specifically in probably based in Germany. This is the plan, and this is where the people I'm interviewing today are. Okay, more will come, but as you probably know, I see Germany quite language specific as a French country can be as well. So we realize and we understand that if we want to have customers looking at us, then we also wanted to have some local German speaking resources also to address this market.
Fully agree what you say. Yeah.
Hopefully very soon, you should, in your region, you should hear about us much more. And we also have started some press release, by the way, that we sent one earlier this week. Another one should be released next week, that are supposed to be translated not only in English, Dutch, or French, but also German. I'm sure of that, by the way. So hopefully we will make more, will be more noisy in a short time frame.
Sounds very good, Bruno. Also, by the way, you have a great white paper about ITRenew and the circular economy, and it's available also in German. So OCP was involved in the translation. So maybe this is also a good thing to really distribute it and make people aware of it. It's available in German, and maybe you guys can just share it with people. All right?
Oh, yeah, you're right. Thank you.
Great. Thank you, guys.
Thank you.
Perfect. So that brings this session to a close. All of the material, the videos, the slides will be made available after the conference on the Sustainable Places website, on the SDIA's website. So Bruno, I just ask you to finish with sort of a 30-second sort of breakdown of where you're going, what you guys are doing, and where people might be able to contact you or read and find more information.
Yeah, sure. So first of all, thanks to all for attending these sessions, and I hope and I guess that you've been very sensitive about the ITRenew message first, about, let's say, saving the planet, shall I say? But also, I don't know how you can get my contact information, but just quickly, my phone number is +336 84 83 58 54. Then you can also reach me by email, bruno.fouquet, F-O-U-Q-E-T, @itrenew.com. And besides that, we've got some R&D teams in France. We've got some warehouse and production line in Sweden to cover all EMEA. So please note that on the EMEA or European standpoint, we're very local. So we also save carbon in transporting things and manufacturing them. And I will be pleased to address any requests you may have, so feel free to contact me, and then we will see how we can help. And thanks Mohan and all the team for organizing this event, by the way. I saw the background, so it's not all time easy to have everything perfect. And
yeah. Thank you, Bruno. Thank you for your time today. So what we'll do now is we will break for 7 minutes. So we'll be back at 10 o'clock UK time, 11 o'clock European time. Unfortunately, because we've had some technical issues this morning, what we will do is we will restart the session, which means you will have to click the link to rejoin. Click the registration link that you previously used to get into this. You'll have to click that again to rejoin the session. Unfortunately, we've just had some technical issues, so we'll reset the system, and that will take about 5 minutes. So we'll break for 7 minutes, and then we will start again with Beth and Deborah Andrews with their presentation. So thank you, and I will let Giuseppe end the session there.
Yes, thank you. 5 minutes, and we're back now.
Perfect. Welcome back, everyone. Thank you for bearing with us through those technical issues. We've restarted the system, so hopefully everything works now. What I'll be doing is I will be showing Beth Whitehead's presentation. Beth Whitehead is a sustainability engineer at Operational Intelligence, and she will be talking through why curving the line, circularity in the data center. And she is unfortunately not able to join us for the Q&A. So Deborah Andrews will be joining us. Deborah is a professor at London South Bank University. So we will now play Beth's presentation, and Deborah will follow up with the Q&A.
Hello. Today I will be presenting Curving the Line, Circularity in the Data Center Industry. My name is Beth Whitehead, and I am an Associate Sustainability Engineer at Operational Intelligence. We are engineers that use collaborative working with a blend of consultancy and training to reduce data center risk, energy, cost, and environmental impact. And my particular area of expertise is in data center lifecycle assessment. Deborah Andrews, who is doing the Q&A session, is an Associate Professor of Design in the School of Engineering at LSBU, with 20+ years of experience in sustainable design and manufacture and the circular economy. So, first a little bit of background. Since the inception of the internet in the 1980s, the number of users has grown to over 4.5 billion people, and 59% of the global population are now connected. While devices such as desktop and laptop computers and mobile phones serve as human digital data interfaces, the hidden but critical enablers of connectivity are data centers. These facilities can be as simple as a single rack in a server closet or as complex as a large warehouse, but all house digital data processing, networking, and storage equipment. Such is the popularity of the internet that in 2015, the number of data centers around the world peaked at 8.6 million. And although their numbers are showing a downward trend, our reliance on them continues to grow. Access to cheaper mobile technology, the increasing digitalization of our world, and more of the global population connecting and on more devices is one part of this growing reliance. The fourth industrial revolution, in which we embed technologies and infrastructures of the third industrial revolution in new ways within society to create cyber-physical systems, is driving this increasing connectivity. As the fourth industrial revolution progresses, the volume of data generated by an expansion of services powered by the Internet of Things in creating smart cities, alongside other data-intensive technologies like AI, blockchain, and robotics, means our demand on data centers is ever increasing. Indeed, the World Economic Forum predicted that by this year, more than 50 billion things, ranging from cranes to coffee machines, would be connected to the internet. Although recent estimates by IDC suggest this to be lower at 41.6 billion connected things, generating 79.4 zettabytes of data by 2025, it's clear that our reliance is in a period of explosion. As our connectivity increases, data center numbers are showing a downward trend and a slowing in the increase of energy consumption due to efficiency measures. For example, virtualization has led to diminishing growth rates in shipped server numbers. The movement of services to co-location and the cloud allows for maximum productivity and better utilization rates, and power demand per server has plateaued, all of which have led to improved energy efficiency. However, our reliance on them continues to grow, and with concerns starting in a period of low renewables content in the grid, the industry has historically focused heavily on energy consumption, meaning our approach to materials use has been sidelined. Although ICT has become more energy efficient, rebound effects have led to a higher demand and more devices, cancelling out any potential to save overall impact. The fourth industrial revolution sees us manufacturing more components to support and enable the Internet of Things and smart cities. Although digitalization and the Internet of Things are theoretically enablers for a decrease in resource demand, enabling multiple users of single smart devices, software-induced obsolescence means in practice the opposite is happening. As grids become more renewables-based, we need to expand the boundaries under consideration beyond just energy and to consider more holistically the way in which we use resources. Let's have a look at problems associated with a linear model of consumption for servers. In a linear model, we take resources from the ground, make them into servers, use them, and then dispose of them. First, we take raw materials. These are finite. We don't have an endless supply and are often stockpiled. They will run out, and the ICT industry is not the only industry using them. In addition, many of these raw materials are considered critical. Critical raw materials are politically volatile, with most supplies imported from outside the European Union and are of high economic value and result in low security in the supply chain. They are essential to the data center industry, and disruption in their supply would negatively affect the digital economy. Critical raw materials are mainly found in batteries, drives, like hard disk drives and solid-state drives, PCBs, and connectors. The most abundant critical raw materials found in servers are neodymium in HDD magnets, cobalt in batteries, and silicon metal in the integrated circuits and PCBs. Then we make a product. Here we need to find new ways to reduce our reliance on critical raw materials and overall material consumption. For example, shared fans per group of servers rather than fans per server can reduce material consumption. In addition, OEMs often manufacture servers which reach an end of life through software-induced obsolescence rather than a functional or material end of life. And a lack of standardization in design and gratuitous differentiation between different generations of servers means reuse and refurbishment is often difficult. The industry needs improved policy and guidelines to prevent these barriers to life extension of products. During the use phase, product lifetimes are often short and trust in data sanitization low, meaning many items are crushed before the end of their usable lifetimes. Fear of data loss also leads to stockpiling of unused equipment, meaning materials are unused but not unreleased from previous products. Also, over-provisioning and redundant servers left plugged in sees servers online but doing little or no useful work. Misconception of secondary goods as inferior and warranty-free means secondary and tertiary markets are yet to be fully realised to their full potential and has led to procurement barriers to their use. Finally, we reach disposal. E-waste is growing. Global IT waste is set to exceed 120 million tonnes by 2050. In the 4 years between 2019 and 2023, almost 46 million servers will be decommissioned. In addition, recycling rates globally are low. In the EU, just 35% is officially reported as properly collected and recycled. However, the global average is much lower at 20%. Much of the remaining 80% goes to landfill. This means we are burying large quantities of valuable materials. For servers that are recycled, critical raw materials have very low and negligible reclamation rates. Often materials are hard to recover as they are mixed within products, such as antimony, used as a flame retardant in PCB plastics. We also don't have the infrastructure for dealing with this waste. The reprocessing methods used are underdeveloped, and the process of recovering materials and metals is expensive. Consequently, there is a real and urgent need to address this now. We can't continue as we are. The Lean ICT report showed that our current global digital consumption is resulting in unsustainable levels of energy and materials use, and the fourth industrial revolution simply won't be possible under our current linear model of consumption. We need to curve the line and close the materials loop now, adopting a circular economy in which we use a life cycle perspective, considering material and energy use, economic and social impact at all phases of the life cycle, eliminating burden shift, and work collaboratively in a multi-stakeholder environment to find solutions. With a closed loop, we can maximise the inherent value of materials within products, ensuring secondary and tertiary lifetimes of products, and creating secure supply chains. In adopting regenerative circular models of business, we need to take less raw materials, improve design to reduce material consumption, investigate material swaps, and end gratuitous differentiation between generations of models, and to ensure ease of reuse and refurbishment. Stop the stockpiling of products and materials with high material value. Use open-sourced hardware and software, making sustainable ICT available to all and to end planned obsolescence. We need to enter into a period of digital sobriety where we move to leaner ICT, where we use the least powerful equipment possible with the longest lifetimes and put a limit on unnecessary energy-intensive uses. Reframe end of life as end of use and waste as a valuable secondary resource. Lengthen lifetimes through reuse and refurbishment, and build the infrastructure to improve material recovery outcomes at the end of use. For digitalisation to deliver environmental sustainability, we need to decouple environmental impact from economic growth to ensure the economy can recover post-pandemic. In the period from 1995 to 2017, although the EU and US saw a slight decrease in carbon emissions and energy consumption, alongside continued growth in ICT and GDP, in China and India, energy consumption and emissions increased significantly, alongside much greater economic growth. Post-COVID-19, the industry should seek to rebuild the economy through circular business models to ensure we alleviate pressure on raw materials, energy and end-of-life infrastructure, and to ensure economic growth and a reduction in unemployment rates. So, now to introduce CEDaCI. CEDaCI, a circular economy for the data center industry, aims to enable trans-sectoral and transnational learning and develop circular economy solutions for the data center industry in Northwest Europe. It is an EU-funded Interreg project with an initial focus on critical raw materials and servers. The project will build a circular economy for the data center industry. To increase dematerialization through improved eco-design guidelines for circular economy, extend product life through equipment reuse and refurbishment, increase reclamation and reuse of critical raw materials in the sector, reduce the use of virgin materials, waste and environmental impact arising from the growth in redundant equipment, develop a secure and economically viable critical raw materials supply chain for the sector, increase collection, processing and recycling in the EU and adherence to EU regulations, provide an approach that can be applied to all equipment within the facility, create jobs in Northwest Europe, decrease illegal export of sectoral limit stockpiling of resources overseas, and ensure the control of Northwest Europe data center industry materials supply chain and manufacture. And here is our vision for the project. CEDaCI is an interdisciplinary multi-output initiative that uses whole life cycle thinking and brings together a network of stakeholders from all subsectors of the data center industry to share knowledge and collaborate to develop a sectoral circular economy. It will reduce waste and prevent supply chain problems to secure uninterrupted data center operation and service in the future. The project has 4 project partner countries, the UK, France, the Netherlands and Germany, with a lead partner in each country and additional sub and associated partners. The lead partners are LSBU in the UK, WeLoop in France, Green IT Amsterdam in the Netherlands, and the Wuppertal Institute for Climate, Environment and Energy in Germany. For the industry to grow and adapt, it's important not to exist in silos. There must be opportunity for knowledge transfer to ensure methodologies are created collaboratively through an understanding of the whole problem and not focused on small parts. This approach helps individuals to gain ownership of problems and breaks down contractual boundaries over which knowledge wouldn't normally flow. Each member of the project team therefore brings expertise from different areas. This knowledge base is increased by working groups in each country which support and guide the research process through working group meetings and national and international co-creation workshops. These include people with knowledge of the full life cycle, including those involved in the supply chain, design, manufacturing, R&D, procurement, use, transportation, data sanitization, reuse and refurbishment, recycling, and policy and communication, and are all members of the wider CEDaCI network. The multidisciplinary, transnational, knowledge-sharing CEDaCI network brings together stakeholders from all life cycle stages and subsectors, directly and indirectly associated with the data center industry. The aim of the network is to maximize transfer of expertise between stakeholders and the project, demonstrate the feasibility and benefits of circular economy practice, and boost sectoral uptake. Members can share ideas within a multi-professional network and inform the research process, access innovative insights towards circular solutions, for example, case studies, test, develop and use circular business models and CEDaCI, the Circular Data Center Compass, which is a virtual decision-making tool, and enlarge their national and European business network and identify business opportunities. And anyone with knowledge or interest in the topic can join. Working alongside our working group members, 3 integrated pilots covering 3 life cycle stages, design and manufacture, life extension and end of life, will allow for the following outputs. eco-design and design for circular economy guidelines to accelerate manufacture of circular economy fit products, life cycle assessment methods and a database of components and materials, CEDaCI, the virtual decision-making tool with a multi-step approach to optimize circular economy business models, and improved refurbishment, recycling and reclamation strategies for and critical raw materials. These outputs will feed into bespoke one-to-one technical assistance, including CEDaCI training sessions for 50 SMEs, advice and guidelines for policy influencers and makers, eco-design guidelines for circular economy, a physical and virtual demonstrator that explains the CE context, processes and benefits, and development of a circular economy for the data center industry. A long-term strategy with 10-year maintenance plan will ensure the project impact and long-term legacy. Originally named as the decision-making tool, CEDaCI, or the Circular Data Center Compass, is currently being designed and developed by the CEDaCI team to guide and support the data center industry in implementing circular solutions in their day-to-day activities. The potential key features of the tool are assessed through 3 perspectives: design, remanufacturing and recycling in the UK, and through 2 groups of experts in the Netherlands looking at design and supply and refurbishment and recycling. That draws my presentation to an end. Thank you for listening. Deborah will now happily answer any questions you might have, and if you have any further queries, please feel free to reach out through our contact details below.
Thank you. So that was Beth Whitehead, Sustainability Engineer at Operational Intelligence, and introducing also the CEDaCI project. So I'd like to invite Deborah now to the stage. Deborah is a professor at London South Bank University. She will be answering our questions. Hello, Deborah.
Hello. I think you've given me a promotion. I'm an associate professor, so thanks for that. Anyway, okay.
First question here from Neil. How do you disseminate your key findings to the data center industry representatives?
Okay, we have a number of platforms. We are avid users of social media and have the usual, LinkedIn account, etc. But we also have a website dedicated to CEDaCI through ITRenew. That's the sort of general, gives you a general overview, and then very specific details are found on our own CEDaCI.org website. We attend a lot of events like this, and also events like Data Center Dynamics, Data Center World, and so forth. So we're very keen to reach as wide an audience as possible. But we also have, as Beth mentioned, a network, and anybody can join the network, and through that you will have access to the tools and various things that we are developing at the moment. The idea of the network is not only to link, for us to disseminate information, but also to link experts who don't normally talk to each other, because I think most people who work in the data center industry are very aware that it's a sort of silo-based industry. So there's a massive amount of expertise, but people don't tend to talk to each other. And one of the sort of USPs and really positive outcomes from the CEDaCI project is the fact that we are bringing people together who don't normally talk to each other, so that's very positive. If you join the CEDaCI network, in the future you will have access to the tool, as we've already said, the Compass, but we're also going to offer training to SMEs, not only on how to use the tool, but about the digital circular economy as a whole. So, yeah.
Okay, thank you. I have a question on the recycling infrastructure across the world. So you said, or Beth said in the presentation, that Europe was doing the best. It's still only 35%. How do you see the recycling infrastructure changing, or how does it need to change?
Okay, well, the problem with sort of recycling is that it's very, very difficult to get accurate figures about recycling rates. We know that the UN have collated a lot of data, but they have looked at formal sort of regulated recycling, and we know that there's an awful lot of stuff that goes on informally. It may or may not be hazardous or safe and so forth. In Europe, the sort of formal rate of recycling is recognised as 35%. So the recycling infrastructure, the part of the challenge is that the industry, the data centre and other electronic industries have developed so rapidly, and everybody's sort of kept running really, really hard to keep the whole network and so forth operational. And the other considerations of end of life, like the recycling infrastructure, haven't really been addressed as much as they should have been. So up until recently, there are two sort of major challenges. One is economic and the other is technical. So in order to make recycling really economically viable, obviously you need to reprocess at scale. So there's been limited investment in developing the infrastructure, limited economic investment in developing the infrastructure, and that has sort of prohibited collection of stuff at scale. So it's a sort of a nexus of problems, if you like. However, there's a huge amount of research in recycling and gradual development of an infrastructure. There are recycling plants. A lot of the equipment, the big items, if you like, the big components are comparatively easy to recycle, like casing, chassis, etc. But the biggest challenge, of course, is all the electronic components. And there's a lot of research looking not just at the challenge of recycling and how to extract the various critical raw materials, for example, from it could be shreds or whatever, shredded materials, but also there's a lot of work looking now at changing the materials and manufacturing processes for electronic components themselves in order to improve recycling rates and reclamation of not just critical raw materials, but all raw materials. So it's a slow process, but there is, we're generally very optimistic about certainly the potential of what can happen. And another thing that has been discussed but isn't yet being practiced is mining of landfill sites, because there's a huge amount of resources in there that are just sort of sitting. Some may be degrading and seeping into the water table and so forth, but an awful lot of stuff is sort of comparatively inert and it's sitting and waiting to be dug up and processed in recycling plants. So we've got an awful long way to go. There's one of our partners in the CEDaCI project is particularly interested in developing metals reclamation plants in the UK, because at the moment the main European recycling plants are based in Germany. So if there's anybody who has a large amount of money and wants to invest in something, new business in the UK, I'm sure we could advise them about that, which would obviously contribute to maintaining stability in the data center industry in the long term. Okay.
And it is very necessary, isn't it? Because like Beth's graph there she showed, electricity consumption and CO2 production has been flat or growing moderately, but actually resource consumption is quite rapid, and it's gone under the radar for quite a few years.
Yeah. I mean, oh, sorry. Yeah.
No, after you.
Oh, sorry. Yeah, I mean, projects like OCP are doing really interesting things, because just to be clear about the circular economy, it's not just about recycling, it's about all sorts of other things as well to improve resource efficiency. So the first thing is dematerialization, making products that use less materials, but that doesn't compromise functionality, obviously, and then reuse, refurbishment, etc., also very much part of the circular economy. that is critical at the moment because we haven't got an adequate recycling industry to deal with all the stuff that's, you know, come to end of life. But in terms of dematerialization, certainly OCP are doing very interesting work by stripping out unnecessary components and, you know, sort of building service systems that are rack-based rather than sort of focusing on individual products that slot into racks. So dematerialization it's starting, but again, it's sort of fairly embryonic and limited to OCP at the moment. But that doesn't sort of change the fact that we are using a huge quantity of resources, and it's not sustainable. You know, we all see sort of infographics or whatever about the quantity of materials. Basically, at the minute, we're using well over 1 Earth's allowance of resources per year. We're heading towards 3 times the Earth's resources. Well, we're consuming 3 times the Earth's resources. So we've really got to put the brakes on and think about developing circular process to keep materials in circulation rather than dumping them. And then that in turn will help us to reduce our overall resource consumption of virgin materials, etc. Yeah.
And so a lot of this occurs actually in the design stage, right? So it's all right at the beginning. If you fix it at the beginning, then you have a huge benefit throughout the life of the server or the piece of equipment.
Yeah.
And that includes dematerialization, but also designing with recycling in mind, designing and reuse in mind, and so on and so on.
Yeah. At the moment, and this isn't just typical of the data center equipment manufacturers, it's endemic across all industry. Products tend to be designed with sort of short life expectancy, or designed for a comparatively short life, so that new versions of products can be introduced and they'll be attractive to consumers. Consequently, well, that's all fine and good, but there's very little modularity. So if you want to repair things, it's very difficult to replace, you know, components and so forth. But also, that aside, an awful lot of components are not designed with repairability or recycling in mind. So we all think of our beautiful slim tablets and phones, etc. One of the reasons why they're slim is because the components are glued together. They're not, you know, mechanical fixings like screws and so forth aren't used. So that makes disassembly very difficult. So the design phase is critical to all this, and thinking about designing for modularity, so that upgrades can take place comparatively easily. If something breaks, it can, you know, components can be swapped. I know there is some hot swapping in service, etc. But an awful lot of products, if they break, that's it. It's really difficult to repair and recycle. So we need to design for disassembly, basically, to facilitate repair, reuse, and recycling.
Excellent. I think that brings our session to a close before we start with Sophia's presentation next. So Deborah, I'd like to give you just 30 seconds on where people can go to sign up to Project CEDaCI and where they can go to find out more information, what they can do to help.
Okay, well, Beth certainly had, you know, very clear links to, well, her email, my email, the CEDaCI email at the end of her presentation, so please look at that. But also look at cedaci.org, that is our website, and there are links to the network there. And we're a broad church, we welcome everybody. We are particularly interested in getting designers to join our project. We've got lots of representatives from stakeholders from different life cycle stages, whether it be, you know, from sort of inception to through use and recycling, reuse, etc. But we really would like designers to join. But we are very, very welcoming. So please come and find out more via our website. Okay.
Brilliant. Thank you, Deborah.
Thank you very much.
That ends Deborah. Thank you. And now I'd like to introduce Sophia Flucker. Sophia is a data center expert at Operational Intelligence. She will be presenting on total data center environmental impact. So hello, Sophia, welcome. Welcome to the final presentation of the day. If you want to introduce yourself and then talk for about 30 seconds before I play your presentation.
Sure. Hi, my name is Sophia Flucker. I'm a Director at Operational Intelligence. So we focus on supporting data center operators throughout the project lifetime. So a lot of that is around optimizing energy performance, but of course also managing reliability and risk at the same time. So Beth is one of my colleagues. I'm sorry I couldn't join earlier to see all of that presentation, but I'm definitely much less of an expert in the area of data center sustainability. My presentation, I think, is more of a kind of introduction to some of the key themes, which I know that Deborah has also explained in a lot of detail in the earlier session.
Perfect. So we'll play your presentation now. So Sophia, if you could mute yourself and stop the webcam, and then the system won't get confused.
My name is Sophia Flucker. Welcome to my presentation on total data center environmental impact. So in recent years, data centers have improved their energy efficiency, but there's still a long way to go in terms of becoming truly sustainable. In this presentation, I'll give you an overview of the current landscape and discuss how data centers can become more sustainable beyond energy efficiency. Our company, Operational Intelligence, are data center specialists, and we provide services to optimize risk and energy performance throughout the project lifecycle. Our team contributes to research and standards development in data center sustainability. Let's start by looking at trends in the industry. We see ongoing densification. So as computing performance increases, one of the impacts is an increasing heat load per footprint and also higher temperatures emitted from the IT hardware. It's necessary that our cooling systems design adapts to cater for these changing requirements. This increasing densification is leading to a growth in liquid cooling, a trend which we see continuing. There are different types of liquid cooling. The slide showing a couple of options. On the top left, we have liquid on-chip cooling, where a fluid, usually water, is piped to and from the highest heat load components on the printed circuit boards, and we have a heat exchange via a cold plate. This is supplemented with air cooling for the other components. An alternative to this is immersion cooling, where the hardware is suspended in fluid, such as an oil, to remove the heat. These types of cooling potentially allow higher grade heat to be recovered, which makes heat reuse more viable. The link on the slide is for a London South Bank University project, where they are looking at a district heating and cooling network, which incorporates data center waste heat. Another trend is higher temperature operation. The diagram on the top left shows the ASHRAE recommended and A1 allowable ranges for air temperatures at the inlet of IT equipment. So this is a psychrometric chart which has been defined with Technical Committee 9.9, incorporating all the major hardware vendors. These ranges have expanded in recent years, and this is able to drive higher temperature operation, which allows reduced use of refrigeration and also more free cooling hours. As the range is expanded to permit lower humidity, this reduces our humidity requirements. So plant can be sized smaller and it doesn't need to operate so much. So this has potentially got a water saving also. We're seeing more data centers making use of free cooling. So the diagram on the right hand side is a particular design using direct fresh air free cooling. You'll see there's no raised floor and the air is delivered via a roof mounted air handling unit, which is supplying air to the facility below. This image shows the results of a study we've undertaken to analyse free cooling potential in different climates. The assumption is an optimised cooling design based on indirect airside free cooling, which uses adiabatic evaporative cooling rather than compressor-based cooling. The locations with a green dot can use this technology and supply air within the recommended range, up to 27 degrees C. Those with a blue dot would have temperatures within the allowable A1 range, which is up to 32 degrees. Locations with a tropical climate, shown in red, would require refrigeration in this kind of system. There are other benefits if you can support a design with zero refrigeration. So not only do you have reduced energy costs from not having to run compressors, reduced maintenance costs where you don't have that plant installed. Of course, there's also the added benefit of reduced capital investment. That's not only in the mechanical plant which you have designed out, but it's also in any electrical infrastructure which would be necessary to support that and to support its peak load requirements. Regulation is also a trend for data centres. On the next slide, I listed some of those regulations which apply. Some of these schemes are not necessarily aimed at data centres, but data centres are affected due to their high energy consumption and emissions. There is an EN standards series for data centres. Although compliance is not mandatory, it provides a framework for design and operation. This includes elements focusing on energy efficiency and sustainability best practices, as well as metrics which measure power usage effectiveness and use of renewable energy. There are a range of voluntary initiatives which look at this area. As well as other environmental standards, there are additional metrics such as carbon usage effectiveness or water usage effectiveness. The European Commission recognises the requirement to improve data centres' environmental performance. Their GPP guidelines, Green Public Procurement, are aimed at helping public bodies procure in a more sustainable way and considered life cycle impacts when producing the criteria. Building energy assessment methodologies have also been applied to data centres, although these focus on the building itself and exclude the embodied impacts of both IT and mechanical and electrical infrastructure. The European Code of Conduct for Data Centre Energy Efficiency has been running since 2008. This supports data centre energy efficiency by sharing best practice guidelines, which are publicly available on the website. Owner-operators can sign up as participants by reporting on their energy consumption and their adoption of best practices. Other stakeholders can achieve endorser status by reporting on how they support data centres in reducing their energy consumption. Participation in the European Code of Conduct for Data Centres is a requirement in some government tenders, and it's also been adopted by organisations outside of Europe. Like other industries, data centres are subject to increased public scrutiny of their environmental performance. One example of this is Greenpeace's Clicking Green report, which in previous years has highlighted which of the big operators are using green energy or fossil fuels. PUE is a metric widely adopted in the industry to measure energy performance. So in this example, we're showing the PUE and the energy breakdown of a legacy facility. So the ratio of total energy being used to the IT energy being used is 2, which means that for every 1 kilowatt we're using for our IT equipment, we have another 1 kilowatt in the supporting mechanical and electrical infrastructure, so in power, distribution and cooling. For a new build energy efficient facility in Europe, we'd expect to see the PUE a lot lower than this. So making use of operating at higher temperatures and free cooling, we might expect a ratio of more like 1.2, which is a big improvement on some of the legacy facilities. Although PUE can be a useful tool to analyse energy opportunities, it can also be misused in marketing. So it's a value that varies with both ambient conditions and load. We need to be clear on which PUE and which assumptions we're talking about when we state a value. In this case, you can see that at 100% load, our PUE ratio, our ratio for the IT load with the total data center load is approximately 1.5. But down at day one, where we first start putting IT equipment in the data center, the ratio is much worse. It's around 10. So if we're designing things and optimizing them for operations, and we're able to reduce our constant M&E loads, so the mechanical and electrical overheads, we can see an improved performance at low load and throughout the data center's facility lifespan. Data center sustainability is about more than just energy efficiency, however. Servers are typically refreshed every 3 years, and the production and disposal of their components has a high environmental impact. Life cycle assessment is an approach which takes a holistic, cradle-to-grave view of a product or service. This means that the environmental impact of all phases of the life cycle are included, from the extraction of materials, manufacturing processes, transport, installation or construction, the use phase, maintenance, disposal, and end of life. Considering the manufacture of components or subcomponents, this process requires raw materials and energy. Byproducts of this are emissions. These emissions cause environmental impacts, which cause damage to air, land, and water. Their environmental impact may be quantified by analysing how damaging this is to areas of protection, usually categorised as human health, ecosystem quality, resource depletion, and climate change. Putting this all together, for a product, the total life cycle impact comprises that of the emissions from its subcomponents, those from combining them into the product, transportation from its location of manufacture to the point of use, its operational impact during the use phase, predominantly energy consumption in this case, and then further embodied impacts associated with disposal at end of life. A system comprises many products, and a building comprises many systems. Usually, focus is only on the energy consumption during the use phase of a building. However, by taking a life cycle approach, the embodied impacts associated with the manufacture, transport, and disposal of all of its constituent parts are also considered. In this LCA of a data centre undertaken by my colleague Beth Whitehead, the facility studied was located in the UK and used free cooling. It was assumed to be fully populated with servers refreshed every 3 years, operating at 50% of their peak power at 30% utilisation. In this scenario, the operational impact was found to be 4 times that of the embodied impact. Scenario 2 considered the same facility, this time located in Sweden, with reduced IT energy consumption and increased numbers of servers. This gave very different results, with the operational impact now half of the embodied. Scenario 3 now considered the same assumptions as Scenario 2, but with the location of the facility in the UK. In this case, the operational and embodied impacts were equal. One way of measuring environmental impact is by attributing points to different areas of protection, with 1,000 points equal to the impact of an average European in a year. This helps with the issue of comparing different impacts which are measured in different ways. This table summarises research findings on the embodied impact of IT equipment, facilities infrastructure, that is power and cooling systems, and the building itself on the different areas of protection. In summary, the IT equipment's embodied impact is around twice as much as that of the facilities infrastructure, in part due to its high refresh rate. The impact of the building is relatively small, hundreds of times less than that of the IT equipment and facilities infrastructure combined. Remember that these two high areas of impact are rarely measured. We can summarise key data centre lifecycle impacts as pertaining to facilities infrastructure and IT equipment. The equipment impact of both is significant. Electronics has high impact, as do the large quantities of metal found in the installed infrastructure. There are opportunities to dematerialise through design by using zero refrigeration, for example. Energy use of IT equipment may be reduced through virtualization and increasing utilization rates. Often there are opportunities to reduce energy consumption of cooling systems, which can be reflected in lower PUE values. The source energy is also important, particularly when this is being consumed on an industrial scale. It is relatively easy to put forward a business case for energy efficiency. Reducing consumption reduces operating costs. Dematerialization can allow reduced capex, and buying renewable energy has an impact on brand value. My colleague Beth Whitehead is currently working on the CEDaCI project to build a circular economy for the data center industry. The aim of the project is to reduce environmental impact by reducing waste and material consumption and extending product life through equipment reuse and remanufacture. You may already have watched Beth's presentation on circularity in the data center earlier this morning. Thank you for your attention. That brings my presentation to a close. Please let me know if you have any questions.
Okay, thank you, Sophia, for that presentation. If anyone has any questions, then please post them in the question bar. But for the time being, I have a question for Sophia. So PUE and efficiency metrics in general, they're useful tools, but they don't tell the whole story. So what is the issue with or what should people be aware of when they use these efficiency metrics? And I think you are muted, so you might have to unmute yourself. There you go.
Can you hear me?
Yeah.
Okay, great. So I think PUE in general gets a bit of a bad press, and certainly it is often misused. So people will use it as a proxy for sustainability and energy efficiency, and they're very keen to report their best PUE, their design PUE, all of those things. I think when you actually look at the real data, what you find on site may not be as good. So I think it's important to be clear on, well, what exactly is it that is being reported on? It's supposed to be the last 12 months average value for a start. And I think a lot of people will tend to be selective about what exactly they'll present things in the best light. So that's one thing. And I think, this is getting standardized now. I think we're at the stage where there's an ISO standard on PUE. So people are trying to take steps to avoid misuse of it in that way. I think where it is very useful is where you're using it in the right way as a tool to help improve your performance. So for us, when we do energy assessments, we will look at the total site energy consumption. We will look at what's being consumed apart from the IT energy. Our focus tends to be on the mechanical and electrical systems, and then try and understand, well, what's the breakdown? What are the largest contributors to your PUE? And then understand, well, where is the opportunity to make savings there? So you'll have seen in the presentation, typically there can be some opportunities, particularly in legacy cooling systems, around operating at higher temperatures, reducing airflow rates and those kind of things. So I think when it's used as in that context, where you're actually not trying to simplify everything just to one ratio, nothing's that simple, but as a starting point for analysis where you can really get into the detail, it can be quite valuable because it's something which is quite accessible to management as well. So you can make the business case for, well, we're measuring this now. We think we could reduce our energy by 10%, 20%. Our PUE would then look like this. My operating cost saving would be this, and it makes it easier to set about putting a business case together, which you need usually to kind of go on that journey.
Right. Next question here from Julia Street. Could you say a bit more about the point metrics for data center efficiency measurement? Where can I find information about it?
So metrics in general about data center efficiency?
She said
more points, about sorry.
Point metrics.
I've realized what that is. So this is something which is used in LCA. So Deborah is actually someone who would know more about this than I do. But there's a particular LCA methodology where they talk about 1,000 points being the baseline for the typical impact of an average European. And this is a way that we can kind of aggregate what's your impact on CO2 emissions, water pollution, all sorts of different things. They're able to kind of put things together, and it's very difficult to measure all of these different aspects because they have different impacts. I can try and find out if I have a link which I could share with you on that. I'm not an expert in that area, but I can find out more about it.
Okay, excellent. And like I said, we can post everything on the website afterwards, all the links, people's contact information, videos and handouts. So that will be available probably this afternoon. Question from me, Sophia. So you mentioned at the start, densification, heat densification in servers. Is that an opportunity or is that a threat, so to speak?
It can be both, I suppose. So I think we can often see challenges in legacy facilities where they're built for a certain density, and then they're faced with having to deal with something outside of what the design was originally conceived for. In which case you're looking at potentially doing upgrades to your infrastructure, and you can have all sorts of difficulties there in that it's not necessarily optimized around that, and maybe there's an element of risk of trying to manage being outside of your design envelope. In terms of opportunity, I think there's definitely growth in the market for liquids cooling of data centers. So we do see it in HPC applications, but it's starting to be further adopted. And there's a certain point at which air cooling becomes unviable. The point is often a lot higher densities than most people would think, because you can do a lot to optimize air to really get a lot out of it. But I think at a certain point, there is a tipping point where we're going to be looking at liquid cooling. And that can become quite interesting, because then we're potentially operating at higher temperatures. Once we've got higher temperature heat being rejected, that becomes more interesting in terms of heat reuse and heat recovery, and certainly moving away from refrigeration and those things. So I think we can see it as an opportunity, but it's early days, and it's difficult to know which particular technology is going to be the one that sticks, and really trying to find the best way which works for a given solution.
Interesting. If we go back to the point you made about legacy facilities, I feel like there's often a mismatch between the facility and the IT. So the IT is refreshed often between 9 months to 3 years, say, and the facility is there for 5+, maybe 10 years, maybe more. And so you have often mechanical and electrical equipment that becomes legacy equipment actually very quickly. How do you align that? How do you make it align? How do you make it work? Or is that just something every facility operator has to worry about?
I suppose it's not exactly true to say that the M&E equipment becomes legacy, because it's partly that the rate of change for technology in that kind of equipment is slower than IT anyway, because you have a lot more IT generations, which is why you're refreshing it so quickly. But you're right in that there is definitely a mismatch, because, as I say, you'll have to make certain design assumptions. So my IT load, my IT density is going to be X at a certain time. I'm designing my power and cooling plant around that. In 10 years time, 15 years time, 20 years time, when I'm still operating in the facility, well, we don't have any idea really what the IT hardware requirements are going to be. So I think it's something that we have to live with, and people tend to tackle it just by trying to remain flexible. So keeping an eye on trends and trying to anticipate as much as we can where things may be going. Modular designs can be good for that. So you just build out what you need for day one. You don't try and build a big space, kit it all out, and then slowly fill it up. That's not very efficient in terms of cost or energy performance often. So it's trying to build in modularity and flexibility where you can. In some cases, I think, again, people see this trend for water cooling of racks. And if they have a chilled water cooling system with air, they might, for example, install pipework underneath the floor in anticipation of running water to the racks at a later stage. So that's one way that you can build in future flexibility.
Interesting. I wonder if there are any more questions from the audience. Feel free to ask Sophia. Sophia is a data center expert, so please sort of probe her brain for this sort of information.
Maybe I could just add something which maybe didn't come out so well in the presentation, but when I was thinking about the title, so I was trying to think about, well, you know, when we talk about sustainability and when we talk about data center performance, it's often just in terms of energy usage, and really that's only part of the landscape. It's a very important part of sustainability, but it's the bit that everyone knows about and focuses on. So I was thinking about, well, the analogy is maybe total cost of ownership, which I think people generally have a good feeling for. So rather than being siloed and thinking, well, at the beginning of my project, I'm trying to minimize my capital cost. If I can cut costs in the beginning, well, actually, I often pay for that during operation. So sometimes you need to invest a bit more to have more energy efficient solutions, which save you money during operation, and that helps you with your total cost of ownership. So it's the same idea that I was thinking about here. It's trying to avoid burden shift. So yes, we can certainly do things to be more energy efficient. I could replace all of my old equipment with new equipment. And yes, that would improve my energy performance. But what's the impact on materials and on that embodied energy and those things? Certainly there is one. it can be quite hard to measure that. So how would you know that you're actually overall making an improvement? Maybe you're just shifting your burden, so you can feel better about things, you're saving on your operating costs, but your environmental impact could be the same. It could be worse even. So it's this difficulty of really measuring our total performance, which I think we need to have better tools in order to do that.
And have you come across any of these tools? You mentioned ISO standards, EN 5600, green procurement, public procurement, I think. Are there, so everyone is waking up to that kind of operations phase. What about the rest of the supply chain, the rest of the value chain? Are there tools for that?
I mean, I think the difficulty is that life cycle assessment is complicated, and although there are databases for materials and those things, you do tend to get quite broad ranges in data. It depends what assumptions you make, so it's not so straightforward. And I think you can spend a lot of time and resources doing a study, but we maybe need to bring that back to a way which we can make a better business case for. So certainly, yes, if we can design things more simply, there's a dematerialization, potentially there's a cost saving. That might not always be the case though, it may not be an obvious link. So I think at the moment, a lot of the guidelines that I've seen, some of the references I made in the presentation, they're about doing the right thing, but the recommendations are more in general terms.
Right.
It's very difficult to make very specific things to say, well, if you chose this option over that option, you'd have a carbon saving or point saving of X or Y. That analysis is going to vary from case to case, and it's not that easy to have access to accurate numbers to do that.
Yeah,
that's part of the challenge.
It's the awareness and the transparency, isn't it? Even if you wanted to make a better decision, how would you know it is better?
Exactly.
Yeah. We do have another question here from Julius Street. Do you advise only data centers or also businesses that rent facility space?
So we look at all different aspects of the data center market. So often we're working for end users. We do quite a lot of work with colos. Part of what we do actually is trying to bring down the barriers between the different stakeholders, because actually everyone has a role to play there. So sometimes we're working for the outsourced maintenance team. It can really be anyone at any stage of the project.
Perfect. We wanted to launch a couple poll questions, but unfortunately we couldn't launch the poll through the video. So now, Giuseppe, if you want to launch the first of the two poll questions.
Yes, here we are. The first poll is now online. So please select one of these options.
Yeah, so the first poll question, which of these regulations have you heard of? And in the meantime, Sophia, I think you can still hear me, can you?
I can, yes.
Another question from me. So like you mentioned, you started your presentation on energy efficiency and energy consumption, and therefore emissions reduction. And then you moved towards the end towards what I think what CEDaCI is doing, which is more to do with actually raw resource consumption as well. Have you noticed this shift in a lot of in perspective from a lot of your the companies that you work with? Are they more aware of this, of the resource consumption element now than they were 5 or 10 years ago?
I think some people are starting to be aware of it, but I think there's a long way to go. I think, you know, energy consumption, it's very obvious that if you save energy, you can save on your electricity bill. The resource consumption, I think often it's someone else's problem. So if you're a colo, it's your customers who are doing the high IT refresh. I think in the context of all the other things that people have to worry about, it's pretty low down the list of priorities, as I say, because it's very hard to quantify what kind of impact you're having. So I think we need to be able to measure things before we can really make the case for change. Yeah,
so that is fundamentally what we're trying to do, I think, at CEDaCI and also at the SDIA is if you don't have any sort of transparency, if you can't report, if you can't measure, then you can't benchmark and you can't make decisions. So that reporting, measuring is so fundamental before an industry can move to the next step. I've just seen that unfortunately can't enter multiple answers into the poll question, which is a little bit frustrating. So I know that
I noticed that some people did respond, so some people have heard of some of the regulations. So
okay, that's the important thing. Yeah. Okay, and the poll is closed. Okay, so I think that's all for the questions. We're near the end of our session. So if anyone has any last minute questions for Sophia, please post them now. Otherwise, Sophia, I'll give you 30 seconds to talk about operational intelligence and how people can get in touch with you, what you're doing, where they can find more information.
Sure. Well, I don't know if you just wanted to share the link to our website. So there's quite a few publications we've written in the area of both data center sustainability in a wider sense, but also energy efficiency for data centers and making the business case around that. So some of these are more kind of technical academic white papers. Some of them are much shorter articles and videos and presentations. So if people want to know more about the subject, that's probably a good place to start. And also feel free to contact me if you have any further questions.
Perfect. I've posted those into the chat, into the questions. So thank you, Sophia. Thank you for your presentation. Thank you for your time. That concludes day 4 of the SDIA's track. This was the SDIA's hardware session. Ali Fenn, President of ITRenew, gave a lovely presentation on why clouds are not linear. Deborah and Beth talked more about Project CEDaCI and circularity within the data center, and Sophia also gave us a little bit more information on environmental impact of data centers. As I said before, everything will be online, handouts, videos, and so on. They'll be uploaded. So please make full use of those resources. But for now, thank you from me. Thank you, Sophia, for joining us. And thank you, attendees, for joining our sessions.
Thanks, Mo.
Thank you and goodbye.